Hey, good afternoon, many. Good morning for others. Welcome to our Diagnomatic webinar on the software. We're going to focus today on do a quick walkthrough of the software, but then we're also going to look specifically at the ACR medium phantom and imaging or testing those phantoms. Couple of items. First of all, I'm Tom Douglas. I'm our sales manager in the Americas, and we will be recording this. So if you are joining us on StreamYard, thank you. If you're watching us on LinkedIn, thank you as well. If you have questions as we're going through it, there's a comment box within StreamYard. Type anything in as we go through. I'll try to answer them best I can as we go through this. If it's something I can't, I'll be sure to get back to you. And you can see all of our other webinars on our YouTube page at Diagnomatic. So if you want to do some of the other ones that we did earlier this year and for future ones as well, so you have a place to go for all those. So what are we going to be talking about? Like I mentioned, we're just going to do a quick walkthrough of the software solution. Many of you have probably seen the software, used the software, might be familiar with it. So just going to do a quick layout. Next, we're going to show you how you would actually upload the DICOM images you have for the MRI Phantom, show that process. And then we'll go through all the 7 tests that pop up and what ACR is looking for in each of those, and just a little bit of an explanation. And then open it up if anyone has any questions or anything else that would be helpful. So briefly, Diagnomatic, if you're not familiar with us, we're a manufacturer of imaging phantoms, and we also have a software package as well, also called Diagnomatic, that allows you to analyze the images of all your imaging phantoms and gives you kind of a single repository for your imaging testing. We're going to go a little more into the software here in a little bit. That's just kind of the cover that we're looking at. But the process of using the software is you'll have your physical phantom. It'll get scanned on a table. There's a couple ways that we can run images. If you are using a connector, those images will be sent, pushed automatically to the cloud where the images are analyzed and sent back to you. You'll get an email on it. You'll get a PDF with a report. Then you also have all the images as well within the software itself. What we're going to show today is manually entering in the images, which is another way that you can test your images. But this just shows us the process right here. We have a number of our phantoms that we can use the software. It is proprietary, so fortunately, if you're using phantoms by other manufacturers, they're not necessarily going to work with our software. But we do have a wide range of modalities that they work for radiography, endoscopy, dentistry, number for mammography, CT, and then obviously what we're looking at today with MRI. Briefly on the connector that I mentioned, this is, as you can see here, it's basically a small background or a small application that works in the background. It links all your different imaging devices. So your X-ray machine, your MRI machine, your CT machine. You can have all your images and do all your QA for all your different modalities and have all of that the imaging stored in a single repository. Nice thing about the connector is it only needs to be installed once within a network, and then once that's the case, all your different devices that are part of that network will allow you to send images to that cloud-based system. The other thing too is you can choose the images that you want sent to the cloud, and it's encrypted. That's what that 27001 or the ISO 7000 or 27001 certification is for. So the images that you do send, will be encrypted. They'll be safe. And so that's always an issue with anything medical IT. It always comes up. So it's always a uphill battle with IT for when you start putting images and information to the cloud. So even though we can do a lot of different phantoms, obviously this is the one we're focusing on today. Medium-sized MRI phantom. We got approval for it back in March of last year. That made us the second manufacturer. There's now 3 that can manufacture the medium-sized MRI phantom. More recently, we got the large-sized MRI phantom, the 8-inch phantom. That's the one that was the original phantom with the MR, the ACR MR program. So it's a more mature product, but again, we're one of only 2 that manufacture that phantom at this time. That's going to be a question coming up. If we can use the software with a large phantom, not at this time. We're working on that. It's working with the medium at this time. So, and then the various ACR tests that we'll be looking at today. Geometry, spatial resolution, slice thickness, position accuracy, homogeneity, ghosting, and low contrast resolution. So we'll look at each one of those images, what ACR is looking for in each of those. So what I'm going to do next is I'm actually going to go to our software, give you just a brief walk around for those that may not have seen it yet. But this is, as I mentioned before, kind of gives you a single repository for all of your imaging QA for all various modalities that you may have. Shows you your status of your subscription-based program, the number of tests that you have available to you. We have different levels that give you different number of tests that can be performed. Same with the number of devices that can be part of your overall program, and those can all be modified. That's the nice thing about a software program or an enterprise software program, is we can make or build it specific to your system or to your network. So everything can fit in a single location. So we have just some basic information about your subscription codes up to date. If we register your test equipment, that helps keep the warranty on various phantoms intact. You can see what we're doing on LinkedIn, some of the things. Obviously, we got RSNA coming up in a couple weeks, so we're promoting that. There's also a knowledge base center here on the homepage. This gives you a variety of different videos, training videos, both with the software and then also for a number of the phantoms as well that help you with setup or how to use certain things. So it's a nice tool from that standpoint. And we have where we actually can go straight to a DICOM viewer from the homepage. So if we're looking at all our different devices, we're going to have locations here. We have a single location, single hospital, but if you had different clinics or different hospitals and you want each one to have their own location, this is where you would put that there. Same with the test equipment, all the different phantoms that you're using. Those are all listed here, and then whether the warranty is active or not. So I got a few that I've added on here that I didn't put a serial number in, so it doesn't say I have a warranty, but these other ones have the serial number listed in there. So that's kind of one of the nice things with using the software, is that the 1-year warranty on our phantoms becomes a indefinite warranty, if you will. So from here, this is where we have all of our different machines for various modalities. So from here, we can show where we've done some different tests of the past. We go to our settings here. This is where we can name our machine, location, where it's at, show our default tests, and then we can set how often we want to run those. And then also have the ability to change tolerances. This is all set to the ACR standards, but if you have other phantoms that may have different tolerances in different states, different countries, et cetera, it gives you that that flexibility to change things. So if we were running a test for the MRI phantom, since we're not using the connector, we want to physically add some images, so we're going to add a test and then go to choose the ACR phantom. I'm not sure you're going to see the my open box here where it has the 11 slices, 11 DICOM slices of the ACR phantom. So that's what I'm pulling right now. I'm going to upload them. There we go. Let's save. Let's say a great test. So now it's going to analyze those images. It takes a few minutes for it to do so. It's going to remind you here, hey, try the connector. So it's not a required thing, but tell you that. So in the meantime, go back to other tests that we have in here. Here's what you have set up for various T1, T2 tests if you want to have those separated. We'll show a different test here. Shows the parameters that the test was taken, field strength, etc. This is an older test from back in February, but at least it gives us an idea of what you're going to get with each test. So we'll start with the geometry test here, and there's the DICOM for it. And the geometry accuracy test, this involves making precise measurements of the phantom's dimensions and the MR images and comparing them to known physical dimensions of the phantom. And this is one of the most straightforward assessments of MR quality. The measured dimensions are compared to the true dimensions of the phantom, and a failure in this test indicates that the measured dimensions differ from the true dimensions substantially more than is allowed. Here we can see the actual results of the measurements. The tolerance gives you 2 plus or minus millimeters. These are the true measurements, and then shows what our differences are. So it shows that it's important to measure this. The structures in the body are accurately represented in different shapes and sizes. The measurements made in MRI images, like tumor size, etc., are reliable, and that the scanner is correctly calibrated for spatial encoding. So now if we look at spatial resolution, it's the slice that we have here. The high contrast spatial resolution test assesses the scanner's ability to resolve small objects when the contrast to noise ratio is sufficiently high. It evaluates how well the MRI scanner can distinguish fine images. This is defined by the size of the imaging voxels. These are the voxels down here. Since these voxels are 3-dimensional rectangular solids, the resolution is frequently different in the 3 different directions. The size of the voxel and therefore the resolution depend on the matrix size, the field of view, and the slice thickness. This test utilizes a resolution insert, contains arrays or closely spaced holes. Resolution insert appears in slice 1 of the phantom images, contains 3 to 4 pairs of the whole arrays. upper left, lower right configurations. And all these holes are filled with a little bit of water and creates a bright spot. So visual assessment is performed to see the bright spots in the hole arrays are distinguishable, and examines whether the smallest resolvable holes can be clearly seen and separated from adjacent holes. And so from here, you kind of see them starting to merge together, which doesn't look quite as right. If you have a failure here for a given field of view, the acquisition matrix, the scanner is not resolving small details. Or in this case, right at the 0.9 difference, so we were okay on this one. Next, we have our slice thickness. Slice thickness refers to the thickness of the individual image slices acquired during the scanning process. This represents the distance between the top and bottom surfaces of the slice, or the depth of the section being imaged. The test utilizes triangular ramps or wedges oriented with a known angle to the slice plane. And when the MRI slices through these ramps, it produces a stretched shadow image that can be measured to calculate the actual slice thickness. Thinner slice thicknesses provide higher spatial resolution and allow for more detailed visualization of structures within the slice. And on the other hand, thicker slices can cover a larger volume of tissue, but may result in lower spatial resolution and potential loss of fine details. Here, the measured slice thickness must be within 20% of the thickness. So we need to be within 20%, in this case, 0.7 millimeters of the 5 millimeters. Puts us at the 5.2 of this measurement here. So that puts us at a pass. Generally, slice thickness tolerance should be less than, there should be plus or minus 10%, even though the ACR allows 20%, but 10% is ideal. Next, we have the slice position accuracy. The slice position accuracy tests how well the actual locations of slicers differ from the prescribed locations. The standard method uses two oppositely directly wedges. Slice passing through the exact center of overlap should result in 2 bars of nearly equal length in the phantom image. If the slice isn't positioned properly and off center, the 2 bars will be unequal in length. So in this case, the test uses 2 pairs of crossed 45-degree wedges located in the central sagittal plane of the ACR phantom, and then 1 pair at the inferior end of the phantom, another pair at the superior end, and the vertices of the wedges paired are separated by 100 millimeters. And so when we look at these, slice passing through the exact center of the wedge overlap should result in 2 bars of nearly equal length in the phantom image. And if the slice is off center, the 2 bars will appear unequal in length. So here's where we're getting a measurement of that. With some slight differences. And again, this is, we want it within 10%. This is the homogeneity test. The homogeneity refers to the purity or consistency of the main magnetic field in an MRI scanner. It's a simple test where the image is first windowed to bring out subtle intensity differences, and then the maximum and minimum intensity values are then measured. And then we use a formula called the percent image uniformity. And there's what that formula looks like. So if we get 100%, that indicates a perfect uniformity. In this case, we are slightly above where the tolerance level needs to be. So the good magnetic field homogeneity, this is critical for one, maintaining image quality, ensuring proper performance, frequency selective fat saturated pulses, and helps to optimize the signal noise ratio. Next is our ghosting test. Ghosts are commonly arise because of physical motion during imaging. Could be vibrations of the phantom, patient motion, blood flow, respiratory or cardiac effects. For quality control purposes, we seek machine-related causes of ghosting, which may be caused by eddy currents or a wide range of other problems in the transmit, receive, or gradient subsystems. The ghosting test evaluates the presence of unwanted artifacts in the MRI images, and which can degrade image quality. For this test, we use the percent ghosting, and the specified regions of interest are shown in the diagram, or shown here. And then the mean pixels intensities of the center, or top, center, top, bottom, left, and right are the mean signals, the air outside the phantom. The ghosting ratio then is that formula we showed there. And the absolute value of the differences is used to ensure the ratio will always be a positive number. In general, the ratio should be less than 1 to 3%. So in this case, we were 0.03%. Final test is the low contrast resolution test. Low contrast resolution test, this assesses the MRI scanner's ability to detect subtle differences in contrast. The ACR Phantom uses a series of discs with small holes arranged in a circle of 10 spokes. Score is assigned then based on the number of complete spokes identified. You can kind of see those there. There are 4 sections, and these will be the slice 8, 9, 10, and 11 of the acquisition protocol, and then each slice will have 10 radial spokes. And there are 3 circular structures in each diameter, and then within a slice, all structures have the same contrast value or contrast level, and the spoke structure diameter decreases clockwise from the origin. So you can kind of see here they're getting smaller within there. The nice thing with the software is that you're not reliant on your eyes to determine how well you see them. It gives you a little more standardized way of testing that. So you have a maximum score of 40 spokes. In this case, it's a 1.5 T, so we have a smaller reference of what we're looking for, so we can see the result of all the different slices. 20 visible, we need to be greater than 18. That's what we have there. So once you have all these different tests, you can go back and you can see your trending data of where you've been over time, where these different tests have shown up. So you can see if something's kind of, if you're getting some drift with your testing. You also have the option too, if you want to look at just the full DICOM image, and then you can scroll through and look at each one of your slices. And from here, if you want to make notes or things like that, There's various ways to do that here. So as I mentioned, once you run that report, you're going to receive an email that breaks down each one of these tests, shows your scores, and gives you something you can have a physical documentation of each of your tests. So that's kind of a brief overview here. Again, we're always looking to maximize the software, so the more DICOM images we get, the better. So if you have DICOM images you'd like us to test, see how it works out, please send them my way. Can even give you a 3-month trial of the software if that's of interest. This time we'll see if we have any questions. We have one: if we provide CMP credits for this talk. That's a good question. Unfortunately, no. Let's see, can we revisit the homogeneity testing procedure? Yeah. Just a second, we'll go back to it here. So here's the images that we have. So this is pulling. It's not showing. There's the. It's going to pull from the top part. Oh no, take that back. That's the. That's our ghosting. So here it's really just pulling from. Looks like it's pulling from these two regions. We have a min and a max, then showing that intensity measure at each spot there. So we have a maximum and min, and then creates that percentage image uniformity calculation. Question: the reference values of the test table results are from commissioning values of the ACR scanners or the ACR minimum values for accreditation. This is all based on the ACR accreditation, what they require if the facility wants to get ACR accreditation. So commissioning values may vary for various countries. This is just strictly for accreditation. So it more so affects those in the U.S. That answers your question, Sarah. So I guess we're going to wrap this up in about 30 minutes. That's pretty good. Yeah, if you have any other questions or you want to play with the software a little bit more, let me know. We can get something set up. My email address is on there. It's tom.douglas@diagnomatic.com. And we appreciate you guys taking some time out of your day to join us, and we will see you all next time. And if you guys are at RSNA, come by and see us. We're at booth 1843 in the, I believe we're in the South Hall. So thanks again. Have a great rest of your day, and we will see you again soon. All right, take care.